Back today to teach you about combining like terms. I have my study buddy back here with me. Again, say hi, Ben. And he's a little more alert today. And I'd like to show you something I referenced in my last video, which was Math Jail. I just want to show you that it is a real thing, courtesy of my niece Olivia. It's a real thing, so follow those rules of equations. Okay. We are going to start combining like terms because we only worked with one-step equations before. And in order to solve two-step equations and multi-step equations, we have to be able to turn something that looks a little bit complicated into something that looks a little bit simpler to solve. When we have an expression, that means it's combining terms, but it's not setting them equal to anything else. There's no equal sign. When we're using an expression, we see variable terms and constant terms. The variable terms are the letters that are the unknown value. And our constant terms are positive and negative numbers. Their values don't change, like this positive 5 here. That's always going to be the same value. Our variable terms have a coefficient in front of it. The coefficient tells you how many of that unknown number there are. And you can see for my variables today, I'm using something a little different. I thought it would be easier for you to see. I used Annabeth's favorite pasta shape, which is bow tie or farfalle. And I just put negative signs on the back so that I can flip them over and use them as x and the opposite of x. We're going to use the negative sign representing the opposite of x because x could be a negative number and then the opposite of x would be a positive. So if you hear me say the opposite of x, that's still negative. If you have something like the hair clips or something like that from before, you can use positive as the front face and negative as the back side if that's easier for you. Okay, so let's get started. We have 3x plus 5x plus x. I'm actually going to say it a little differently. I'm going to say it 3x and 5x and x because then we can keep our signs associated with whatever comes after them. That helps when we solve our equations so that we know the inverse operation to use. So it sounds a little weird at first, but it will help later on. Okay, the first thing I want to set up is 1, 2, 3 positive x's. Then I'm going to set up plus 5. Lucky for me, that's just a nickel. And then plus x, I'm going to put that there. I'm going to draw it out here. 1, 2, 3 positive x's. I'm going to use positive 5. And then I have positive x. Well, we know the coefficient in front of x, if we don't see one, is a 1. So I'm going to do a positive x there. What I can do is I can combine the things that are alike. If my variable is the same letter, and in this case it is, x and x, then I can combine those together, and that would just be reorganizing what I have. So I'm going to reorganize all those together. 1, 2, 3, moving this one over here is 4, and then 1, 2, 3, 4. Then I have my 5 there. Okay. All that means is I can write this as 4x plus 5. If you are ready to move on to just using the algorithm, find like terms, my two variable terms with x, add your coefficients, 3 plus 1 is 4. That's 4x. And then I'm going to squiggle that because it's different, it's a constant term. And bring that down, that's just a plus 5. So 4x plus 5. All right, clear off your board, and let's try one that's a little trickier because it involves negative variables. Again, that's why I drew negative signs on the back of my bow tie pasta here. So I'm going to set up, we have negative 5n and negative 8 and 2n. So 1, 2, 3, 4, 5 negatives. 5 negative n's. Then we have negative 8, so I'm going to use negative 5, 6, 7, 8. And then positive 2n. So I'm going to use 2 of my bow tie pastas face up. Okay? When I draw this, I'm going to show you how you can draw your variable in case you don't want to get your manipulatives out, you can set up your pawns and don't color them in, and that'll show that they're negative. So I have negative 5n, then I'm going to use my red. Remember, red in finance means you're in debt or have negative money. Hopefully we don't get there, right? 1, 2, 3, 4, 5, 6, 7, 8, negative 8. And then my positive 2n, again, will be colored in triangles, so I can draw quickly like a mathematician. Now, how can we simplify this when we have positives and negatives? Well, remember how I said that this was the opposite of that? So we can make 0 pairs. We don't know their value, but we know they're the opposite. For example, if x were 2, then the opposite of 2 is negative 2. If x were negative 2, the opposite of negative 2 is positive 2. Whatever the value of x is, the opposite of it is always going to send it back to 0 when we combine them. So I'm combining a positive and negative x to make a 0 pair, and I can remove it because it has no value. Then I can combine another positive and negative n, sorry, not x, make a 0 pair and remove it from the board. What that would look like here is simply canceling out a negative and a positive together. A negative and a positive. You've got to do it in pairs. Otherwise, you go to math jail. So a negative and a positive that are the same absolute value go together to make a 0 pair. Once that's done, all that's remaining, and I'll redraw it so you can see it more clearly, all that's remaining is my negative 3n and then my negative 8. And some people gave me feedback and said that drawing the dots was kind of a pain. So if you put your negatives in a box and I'm gonna slide back up to the first one, and you put your positives, which I should have 5 here, oopsie, in a circle, then that is another way you can do it a little more quickly, and you can use break apart method to solve as you go later on. So what would this look like using the algorithm? Back to the second problem here. Using the algorithm, again, we would identify like terms. So I'm going to look at my variable terms first, and I know if I add the coefficients negative 5 and positive 2, I get a negative 3. So this will be negative 3n. And then I bring down my negative 8.